Okay, these problems are from page 2 of the 21.2C assignment. I picked just a couple of the problems out to do, but I think I'm going to do number 16 before number 12. I looked at them, and 16 does more of what I wanted to do. This says both SAT math and verbal scores are in fact normally distributed. Math has a mean of 480 and a standard deviation of 80, while verbal has a mean of 430, standard deviation of 120. For each of the students listed below, find their z-scores, then the percent of all the students who fell below them in that portion of the SAT exam. When you take a standardized test and they tell you you're in the 90th percentile, what they're saying is 90% of the people scored less than you. I don't know whether these numbers are even close to today's SAT scores, but these are the same numbers that I put in your notes. They're good for working out these problems. Gives you the idea of what's going on. So first of all, I am going to figure out for Sierra, who scored a 720 on math and a 690 on her verbal. I'm going to locate all my math information first. Here we go. Math has a mean of 480 and a standard deviation of 80. Let's work on math first, and then I'll come back to the rest of the information. Here we go. Sierra, z-score equals. On the top of this fraction, I need to know, let me put my little formula up here. Z equals the number you want to know about in the problem, which in this case, well, let's just use the x. I'm writing a formula up here. Minus the mean, and if we're talking about the whole population, we're going to be using the Greek letter mu for our mean, divided by the standard deviation, which is this lowercase sigma. Come down here. The math score I need to know about is 720. And I'm going to subtract from that my math standard deviation, my math mean, which is 480, and divide by math standard deviation, which is 80. Depending on your calculator, you might need to throw some parentheses around there to make this work out for you. Let's see if I can put this in my calculator. This turns out to be just 3. Then I can write that into my table here. Sierra z-score 3. I need to go to the table in order to figure out my next step. I need to find the p-value that goes with 3. Positive side of our table. And here we go. Right down here, 3.0. I don't have more than one place past the decimal, so I don't have to worry about going sideways on the table. But here's my number, 0.9987. The table does ask me for a percent, so I'm going to move that decimal over 2 places and write it right over here as 99.87%. That's only halfway there. I also need to figure out Sarah's information about her verbal score. Z-score again. The actual score she got. It's always whatever number of interest you have in the problem. Go back to the top. Let's figure out my history information. Verbal information. Verbal has a mean score of 430, standard deviation of 120. Subtract the mean, and the mean was 430. Divide by the standard deviation, which is 120. Again, depending on your calculator, you might need to throw some parentheses in there. This one works out to be 2.1. Lots and lots and lots of sixes on my calculator. We can only deal with 2 places past the decimal. So we're going to convert that to 2.17. 6 followed by a 6 pushes it up to a 7. Going to my table, finding the positive side of my table, and I'm looking for 2.1. It's not good enough though. I need a 7 in the hundredths place. So I go up to the top and work my way across the top until I find 0.07. That's that 7 in the hundredths place I'm looking for. These two lines come together here. Oops, looks like I went a little too far on that one. And the number I'm looking for, 0.9808. So I have a p-value of 0.9808. Move it over 2 places. Give myself a nice percent here. 98.08%. And they did want me to write the z-score too. So 2.17. Now, I certainly haven't figured out all of these people yet, but I'm going to look at number 17. It says, for each student above, state which portion of the test they did better on, verbal or math. In this case, Sierra, she got reasonably high scores on both of them. You can compare the z-scores, 3 versus 2.17, or you can compare the percents. 98th percentile on her verbal, 99th percentile on her math. She's good for both. If I was going to write down which one she did better on, I would have to say, though, she did better on math because, hey, math is the best. Everybody knows that. So if I was making a list down here, probably the last thing in my list, since she's the bottom of my table, would be Sierra is better at math. Let's go back and figure out Rami. Rami scored 580 on both of them. Generally speaking, 580 on one test, 580 on the other test, does not always mean the same percentile, does not always mean the same z-score, unless things happen to just work out that way. Looking at Rami. Here we go with Rami. Let's do Rami's math. Rami's math. Z equals, his score was 580, minus the mean for math, which was 480, divided by the standard deviation for math, which was just 80. Throw some parentheses around that if you need them. And this one turns out to be 1.25. I'm going to fill in Rami's math score, math z-score, 1.25. And then I'm going to go to the next page, look for positive 1.25. There we go, 1.2. And I need a 5 in that hundredths place. So I'm going over here and finding this 5, bringing it down here, bringing it over here, and I get 0.8944. P 0.8944. over here in the table where the final answer goes. Move that decimal over, call it 89.44%. Okay. I also need to figure out, what about Rami's verbal score? He got 580 on his verbal as well. But this time, I'm subtracting a mean of only 430 and dividing by a standard deviation, which is higher, because apparently there's a little more variation in the verbal scores. But it just so happens that's also 1.25. Here we go. Rami's verbal score, 1.25. And I don't feel the need to go look this up on the table when it's the same z-score as here. So again, I get to write down 89.44%. It is unusual for two different standard deviations and means to produce the same score here. I think the people who wrote this paper just thought it would be interesting to do that. But when you come further down the page and you read number 20, which says, does getting a 78 in Mr. Science's class and a 78 in Ms. Numbers' class mean they did equally well in both classes? You should still be saying no, it doesn't. It all depends on the mean and the standard deviation. You can't just say, because they have the same score, they did equally well. Okay, I think I'm done with this section.